Thank you very much for attending our UKCRIC Global Outlook webinar. And this is being presented to us by Fatma Keskin, who is currently in Turkey, but has previously worked at the University of Birmingham. So we're really excited to hear from her about her research work. So I will hand over to you, Fatma. Thanks very much.
Hi, everybody. Thanks for joining me today. I will share my screen with you to start my presentation. Can you see it?
Yes, it's just come through now. Thank you.
Okay. So, yeah, I will talk about the reimagining urban generation for sustainable transformation of vulnerable building stocks. Shortly, I will talk about myself. I'm currently working as a lecturer in the architecture department at Mehmet Akif Ersoy University in Turkey. I'm giving some courses relevant to architecture, like architecture projects, structures, building materials, counter building materials, statistics, structure analysis, earthquake factor in architectural design. I hold a PhD in civil engineering from the University of Birmingham, and I have conducted postdoctoral research on the CDAS project, Center for Development of Postdoctoral Researchers in Cities, Infrastructure and Energy project at Cranfield University. My research area includes designing and analyzing buildings for urban transformation with a focus on enhancing sustainability, resilience, and circular solutions for construction demolition waste, particularly in response to disaster impacts. This is my recent research area as well. So I'm currently working with two research groups from Turkey. One is Hacettepe University and the other one is Gaziantep University, both of them from Turkey. Currently, I am working as a researcher under the Seyma engineering and consulting company for the projects Hacettepe University managing, and I also work with ALab company for the projects Gaziantep University involved. So today I will mostly talk about Hacettepe University projects. So our research team focus on the production of 3D concrete, the recycling of construction waste, and the characterization of end-of-life materials, which we refer to as materials passport. Recently, one of our project proposal for DUT, like driving urban transitions, has secured over €2 million in funding for a 3-year project. This project aims to develop circular solutions for the built environment by using construction demolition waste, creating a cadastral approach, tracing mechanisms, disaster waste treatment solutions, and a synergetic market for reused materials will contribute to debilitating urban regions, reducing environmental burdens, costs, and also benefit for the creating jobs, ensuring the security of material supply. So I'm currently focused on integrating a material passport framework and secondary metal information platform. So it is related to the LCA part of the study. This help us to understand the environmental impacts of secondary materials from construction demolition waste. So it includes life cycle process of the materials, like first life cycle, manufacturing process and using this material in building, then second life cycle of the buildings. Why we aim this material cadastry approach, material passport, or construction demolition waste? Because on February 6th, 2023, Turkey experienced two powerful earthquakes with magnitudes of 7.7 and 7.6. These devastating events caused widespread damage across an area approximately 350,000 kilometers square. This is nearly the total area of the Germany, and affected 14 million people, which is about 16% of Turkey's population. The impact was immense, with approximately 400,000 buildings destroyed during these two earthquakes. In the aftermath, it is estimated that around 500 million tons of disaster waste were generated. That's highlighting the urgent need for effective waste management through reuse and recycling. Furthermore, Turkey is in the midst of significant city transformation, like, for instance, Istanbul, facing the challenge of replacing its substantial building stock. And we have so many cities like that, not only Istanbul, like nearly 90% of Turkey under the earthquake-prone areas. So we have so many cities, just like Istanbul, waiting for the urban transformation of their vulnerable building stocks. This will result in high latent demand for raw materials and energy, leading to environmental and health concerns due to the increased greenhouse gas emissions, carbon dioxide emissions, like that. So what is the situation in Turkey right now? We are very good at techniques related to construction waste, but there are no official statistics on demolition waste management or framework. Field experiences show that metal reinforcement is recycled for construction, while concrete waste is often mixed with other materials like bricks, ceramics, tiles, scrap materials, and used for filling or disposed of these concrete materials. What about world situation? So the recycling of demolition waste is being addressed within the framework of the circular economy policy in the European Union. In addition, the transformation of demolition waste into raw materials that can be used in the construction sector is one of the sustainable development goals that overlap with the United Nations Sustainable Development Goals. How it fits with these goals, like building resilient infrastructure, supporting sustainable industrialization, strengthening innovation fits in the SDG 9. Making cities and human settlements safe, resilient, and sustainable fits the SDG 11. And ensuring sustainable production and consumption patterns fits the SDG 12 here. In 2008, the European Union aimed to recycle 70% of demolition waste by 2020 with the Waste Framework Directive. Currently, this target has been achieved with 74% in the European Union in average. In some countries, such as Netherlands, Finland, Germany, and Belgium, the recycling rate even exceeds this one and reached 90% as well. But here you can see the worldwide recycling rate. So as seen in the figure, the annual per capita generation and recycling rates of construction and demolition waste from the various countries around the world. When we look at Turkey's position, a considerable high amount of construction demolition waste generated compared to the size of population of other countries. The large amount of construction demolition waste available in Turkey and the low recycling rate compared to the global average, and when we look at the European countries as well. In addition to the high level of risky building stock leads to significant increase in urban transformation efforts, resulting in more steel, cement, glass, brick, aggregate, and concrete production as well. This is because from 2020 this results, but we had this earthquake in 2023, so we have a huge amount of this construction demolition waste. So all this, along with the growing population and internal migration, increase negative impacts of the country's construction sector on the environment and nature resources. Unsustainable and non-circular approach in terms of consumption and production brings so much challenges for these issues actually. But our researchers, that's why focusing on this construction demolition waste. What is the difference? Well, like we are talking about disaster waste and demolition waste, and all the countries involved in this construction demolition waste approach, and they are trying to reuse or recycle their waste, but there is two differences. Demolition-based results from building demolitions due to the end of useful life and nature resources. So there's two ways. Originating from the same source, but it exhibits significant structural differences. When we talk about controlled demolitions, hazardous and valuable materials can be gradually separated. It means like it's not happen after a disaster. The building can be vulnerable, or the building can be in the end of its useful life. So you can just go and control demolitions can be applied there, so you can do separation properly. But disaster-related demolition waste include mixed building materials. It's like personal items, hazardous and non-hazardous components. So you have to follow different kind of way to separate these components. It is mostly ruins, because after earthquake the building demolished, and it's all ruins and you need to separate. It's quite difficult when we compare the in-control demolitions. So in plant demolition, separation at source is feasible, unlike in disaster demolition, which resulted in mixed waste piles. Sorting mixed waste for recycling afterwards is labor-intensive, costly, and logistically challenging, we can say. So recycled demolition waste can be repurposed in cement, construction production, and construction, leading to reduced carbon footprints and economic benefit. As concepts like resource efficiency, circular economy, zero waste gain traction, the market for recycled demolition products is projected to reach $150 million by 2027. So with recycled concrete aggregates expected to dominate this market. So when we look at how we reuse or recycle metals, scraps we mostly consider, but also the concrete will continue to need for our buildings, as even it is steel structure, it will need concrete and cement. So that's why concrete aggregates take the huge part of this demolition waste market as well. So we can say demolition waste is not waste, but an imported raw material for the construction industry. Regarding Turkey, we have disaster waste. Recent earthquake generated more than 5 million tons of mixed construction demolition waste. We have immense knowledge in the recycling and separated of this waste. Disaster waste should be separated for effective recycling. This is the area need to be developed as well. In Turkey, sorting, separating technologies are well developed so far. So we are ready to use this recycling of and disaster waste to integrate into the circular economy by developing green construction materials. So let's look at what we have from disaster waste. So the investigation at the earthquake site has revealed a staggering 5 million tons of mixed earthquake waste. This includes concrete, stones, tiles, bricks, glass, plastic, aluminium, automobile parts, and mixed household waste even. The entire process involves collection, sorting, upcycling, and the production of new upcycled products. Additionally, there are detailed processes such as storage, import, export, and the impact of utilizing secondary materials on humans and environment. One of the challenges posed by disaster is that these metals are mixed in the affected area, including so many other materials. Due to this complete mixing of this waste, it is imperative to carefully separate them according to their types. Actually. So this is how we separate this waste, starting of disaster waste process. Here is the crushing process take place with masons in the waste storage area. Yeah. So they are collecting with these masons from the rings or from the waste storage area. Yeah. Here is the coarse materials in earthquake waste, collecting and separated in the sieves here, as you see. So it's separated in different sizes. At the end of the process, the rubble is separated into different sizes. So for the production of concrete, we need different size. We are using in different sizes for different kind of concrete or other kind of productions. These are the sieves process again for the not concrete metals but more light metals separating here, and crushing process as well. Maybe wood or some other kind of materials as well in the sieves. Yeah. As you see, there's so many different materials there, and crushing process here as well. Yeah, so much mixed products. Again, some other kind of like the selection process is separated from the materials. Here there's another sieve separating the waste between 15 centimeter and 30 centimeter. And yeah, different kinds of separation processes here for each of the size, for each of the materials. Here is the optic separation. It's look at the color, size of the material and separating according to this one, like with 3D or 3D, 2D or 3D screening happening there, and they make separation according to its colors and physical features. Yeah. So after separating these materials, how we are using, here you're gonna see some current practices in Turkey. There are many different areas these recycled materials used. One of them is mostly actually asphalt coating, road construction, big production. So as you see in the first part, the crushing and grinding part, they're separating bricks, different kind of bricks, roof bricks and other bricks, wall bricks, and concrete there, and glass, crushing and grinding, then using as a producing new roof tiles or bricks. Another way of this, using especially concrete aggregates for the asphalt coating and road construction as well. Another one is recycling of wood waste and producing wood panels, like here. The wood waste turned into the wooden fiber, and then adding some alcohol solution and some other chemicals, and some wooden fibers. Panels containing waste wood chips can be produced on this material. Other one is brick and glass recycling application for thermal and sound insulated panels. As you see, you can have highly insulated panels from these recycled materials. What else? Like some modular system designs, like waste building elements that can be dismantled and rebuilt in different locations, called as modular system from construction waste. As you see, there is a Lego construction system of green structural elements for low-cost housing, like development of new generation binders with construction demolition waste-based materials can be practically dismantled and rebuilt in different locations. High level of strength and durability can be achieved, high mobility allowing it to be built where needed as well. So here is the Prince Edward visited the university for this Turkey's first recyclable housing system project. This Lego system with green structural components for low-cost housing project funded by Newton Katip Çelebi Fund. Then it won the International Newton Prize in 2020 as well. The other one, single-story residential construction. So again, here is the construction demolition waste used for the removal and reassemble some structural elements and single-story residential building built there. The other one is 3D printing. So integrating 3D printer into the construction industry and using best in 3D printing technology. Here we can like produce some post-disaster shelters because as you know, 3D printing technology quite fast. So that's why it can be used for immediate construction of post-disaster shelters as well. What else? Like development of new generation printable building materials that are environmentally friendly and prepared from 100% construction demolition waste is another benefit, we can say. Also economically feasible as well. So again, in this laboratory there is some testing happen, like there is test facilities that are like mechanic and durability performance assessment, development of reinforcing strategies, implementation of modular system on 3D printing walls, examination of the seismic performance demonstration, like so many other tests can be done in this laboratory. So here is the 3D printing process. So what is the difference from the other 3D printing processes? Because it includes construction demolition waste 100%. Yeah, as you see, it can be built very fast. This walls for the buildings. Yeah, you can see this project. What about controlled demolition? We talk about this disaster waste till now, but if we need to make a controlled demolitions, especially regarding Turkey, we have quite huge vulnerable building stocks, and mostly it's their age or lack of structural strength and durability makes them susceptible to future disasters. So urban regeneration projects aim to demolish these buildings and replace them with the new ones. So this picture shows like these people still living in these buildings, but it is quite vulnerable. After this building's demolished, other picture shows like how it can turn to new urban regeneration areas. So this is the general picture from Turkey's situation relevant to vulnerable building stocks and urban regenerations. So I will give one of the example from Istanbul. This is waiting for urban renewal before expected earthquake. So population is more than 15 million, nearly 16 million population we have in Istanbul. I took this example because it has the highest population, but as I said, we have so many other cities waiting for an earthquake actually, because Turkey is generally very big earthquake-prone area. But this example gives you the main important issue relevant to when we consider the whole country as well. Like I want to just highlight this. We had earthquake, two big earthquake, and it was huge, and we have nearly 500,000 tons of waste there. Is certainly sorting and trying to reuse and recycle. The work is going on there, and all the power of the construction industry in Turkey trying to manage this all waste, but also we have vulnerable cities waiting for urban regeneration, and we have huge amount of vulnerable building stock as well. So here is the Istanbul example. Huge population, many neighborhoods, a number of buildings, about 7 million, 500,000. And estimated risky buildings is 600,000. It means these buildings tested and report as a risky buildings, and this needs to be demolished. It means this risky is 600,000, but many experts say it is more than this actually. So estimated tons of reinforcements for metal recycled, only metal recycled, is 2 million, more than 2 million tons, and estimated value of this recycled metal is 520 million euro. Just for Istanbul case, for this estimated risky buildings, but we have so many other vulnerable cities, and we have still disaster waste from the earthquake, the recent earthquake area as well. What is the relation with circular economy? As I said, this is huge amount of money, 525,000 million euro just for 600,000 buildings. So this is related to circular economy, as it includes actions to prevent waste during the design phase, and it not only reduces the waste but also enhances the resource efficiency, contributes to reducing carbon and water footprints, as well as waste disposal costs, creates new job opportunities in waste and recycling industries. Products and materials re-enter the economy, boosting the country's economic growth, supports sustainable development by maximizing the life cycle value of resources as well. So that's why we need to also consider circularity of this waste materials for Turkey case. So till now I talk about the heavily damaged buildings after earthquakes, but we demolish heavily damaged buildings after earthquakes or heavily at-risk buildings for urban regeneration. However, these are also there are also buildings that do not need to be demolished despite being damaged. Like in general, these damaged buildings fall into two categories: low damaged and medium damaged. my PhD also focused on this topic. I developed a method based on the concept of structural intervention, which involves structural retrofitting and reconstruction of buildings. Because for a medium damage building, like for a low damage building, you don't think for the demolition. You just need to be strength to a structural. But for a medium damage building, retrofitting should ideally not exceed 40% of the cost of constructing a new building. So this is essential for ensuring feasibility. But by utilizing this construction demolition waste, we can further reduce retrofitting costs and make it an economically viable option. Right now, this is a big challenge for the medium damage building because, especially in earthquake area, the recent earthquake area, most of the buildings needed to demolished, even it can maybe save with retrofitting because this construction cost is quite high and the structural retrofitting cost also increasing in this way. But if we can use this demolition waste for the structural retrofitting of this building, we can reduce the cost of the construction, retrofitting construction, and also save this building as well. So we don't have, in this case, this huge construction demolition waste probably. So these are the future approaches can be think for the urban regeneration projects as well. But also there is a relation with this, not only about the cost, but also the environmental impacts, because a reduction in the environmental impacts, resource use, we need to think about the service lives of the buildings as well. So we need to think about the life cycle process of these buildings. So as you see this in the figure, there is embodied and operational parts of the buildings from the whole life. So in embodied carbon, in energy, we can see in all the process of the building, relevant the most about the metal production part, but in operational phase, we only think about this using of the energy, lighting or cooking or heating kind of things, we can say. So in LCA and disaster waste management needs to be work together and integrate to evaluate this environmental impact of this building methods and construction techniques for the low damage building, medium damage building, or even if we have this construction demolition waste from disasters, also LCA help us to include this materials life after this, like it's separating like first life cycle and second life cycle as using this metal as a secondary material here. So it also needs to be included, not just circular economy, also LCA of buildings to understand and understand the tracing mechanisms of these materials as well. So in this method, as you see, vulnerability of buildings incorporated into the sustainability concept by generating scenarios related to damage case and customizing LCA stages according to these scenarios. As you see, there is a low damage building. We only think about the structural retrofitting of the building. There are so many alternatives because the technique is developed highly. For retrofitting, structural retrofitting techniques is we have so many alternatives. So we can also compare their environmental impact, like reinforced concrete, jacketing, and steel jacketing options for the damaged columns, for instance, because there are several methods for this one as well. To achieve the best choice, we can also compare these different structural interventions. But also for a medium damage building, as I said, there is a structural retrofitting option, but also there is a new building scenario. There is a cost issue is help us to make decision, but if we can reduce the cost for the retrofittings, we can make benefit from the especially the cost and environmental perspective of the building as well. So yeah, here is you can see some customized stages for life cycle analysis And when we think about the demolition and building a new one, or keeping the building and straightening with structural retrofit options. So like that, like how it can affect it. In our study, we found that opting for structural straightening of existing vulnerable buildings rather than constructing new ones can significantly reduce environmental burdens associated with the construction. As you see in the picture, like we can save around 2 buildings carbon dioxide emissions caused by energy consumption during their whole period of life, and around 4 buildings energy consumption around their entire life. There is two embodied energy and embodied carbon. So embodied carbon can save 2 buildings, and 4 buildings can be saved from the embodied energy. Retrofitting building is so powerful tool for creating a more sustainable future, as we see. So I want to say that like if we think for this disaster-prone area, 500,000 medium damage building in our earthquake areas we have. So thinking like just saving these medium damage buildings with retrofitting options, and utilizing this demolition waste, we can further reduce retrofitting costs and make it economically viable options. Just so this in turn helps us avoid the need for new building construction and aligning with also sustainable development goals. When we use these recyclable metals for straightening, we are not only reducing resource demand, but also lowering the environmental impacts to other issues as well. So this was my presentation ended here. Hope you enjoy. So should I stop sharing or should I keep it here?
Thank you very much, Fatma. That's brilliant. You can stop sharing if you want to, unless you wanted to go back to any of your figures kind of during the question time. And was there anybody who had anything that they wanted to ask Fatma from the people that are in the room? Feel free to turn your cameras on and your microphones.
I've got a question.
Hello, Tom.
Hi, Tom.
Hi, thank you for the presentation. Really great. Just it's about the characteristics of are restored buildings more vulnerable to the next earthquake than their new build equivalents?
Say again, sorry?
Would a building that's been damaged and then restored, is that more vulnerable to the next earthquake than its new build equivalent?
You mean like using the construction demolition waste for the new buildings construction? It can be enough the strength for the next building, next earthquakes, you mean?
Yeah. Is there a difference in performance under the next disruption, the next earthquake?
Yeah, it is actually this in the laboratories. This is the actually main issue related to concrete waste, especially when we using the recycled concrete, because it is not homogeneous thing. This is different kind of concrete materials came from different kind of buildings, and also their strength even different. Like when we look at the vulnerable buildings in Turkey for the risk assessment, normally if it needs to be 30 megapascal, for instance, the durability of the building, we can find even 10, 20. So it's all strength is different, but new technology and systems and grinding processes help us to use this as an aggregate. So after the producing this material as concrete, we do still this compression test, and so test, straightening test, like in the laboratories. And of course, you can't use this material in the construction before testing. You need to done all this testing for the features of the concrete material, but it is a big challenge as well.
Thank you.
I thought the 3D printing of the building was rather fascinating. How they'd is that in one of the laboratories that been set up?
Yeah, in the laboratory there is still going on production process for the low cost housing systems, actually, because after disaster you need some shelters. We have tents for this or prefabricated shelters we have, but most of the time it is insufficient to shelter the people because weather conditions for tent is not it's not useful, or even the prefabricated buildings not enough sufficient for people, because when you think like normal process, it takes around 1 to 2 years to build a new building. In 1 year is quite fast, but in 2 years probably you need to live in the tent or prefabricated building. So we need to also think about what will happen after a disaster if people need a shelter. So this 3D printing opportunities provide a great chance for the fast manufacturing and also safe, and you can also do protection from the weather conditions as well.
And how long would one of those buildings take to construct?
I'm not sure, but I remember it's like 1 week to ready for the people to live in, because it is quite fast producing the walls. After this you need to do some maybe painting or electrical system or some other infrastructure stuff you need to complete this. But as you see, the size is quite small, like maybe just 2 rooms, so small size, but enough for a shelter, for a shelter after disaster.
Brilliant. Shalu, you've got your hand up. Feel free to ask your question.
Hello.
Hi.
Hello, thank you for the presentation. Actually, I want to ask that is this cost effective to recycle this waste?
Say again.
Like, is this cost effective to recycle this waste?
So actually, as you know, like construction industry has the biggest pie for the economic part. The increasing of the metals and cement production. When we think this huge increases after the especially COVID process, industrial challenges and crisis, things it's keep going on rising, unfortunately, especially the construction materials. When we think this process, yes, it is also challenging. Greening, separating, and manufacturing of new materials takes so much process and cost as well. But when you compare with the new building construction of new building materials, raw material mining process, manufacturing process, we can see this concrete can be a bit costly, but metal recycling always more feasible when we think about the economy. But we also need to think about the environmental part. If we think about the sustainability and recycling and reuse process, always more positive contribution to environmental impacts as well.
Okay,
but
thank
you. Yeah, you're welcome. We also think about the circular economy process, because these materials, when we think about the life cycle process of these materials, it will be used as a secondary material after its life. So there is a completed life before, and there's another life after this to be used. So it's also help us to avoid this using raw materials as well. So it's quite beneficial when we think. That's why actually European Union and United Nations, that they take consideration of this construction demolition waste actually.
Yeah, and actually I was also thinking that we can use this as a non-load bearing structure. Like one of our member just talk about the strength. Like I was thinking that we can use this concrete in the non-load bearing structure, like partition walls and all that.
Yeah, this is also, but like mostly it is used road filling, road construction and road filling. That's why if you can't have these techniques to separate this concrete and do some tests, you just need to just go any filling area for the road filling and other kind of fillings and use that. This is another and most widened way of using this concrete. But as you say, non-structural components of the buildings also can be benefit from this waste as well.
Yeah. Okay. Thank you.
Welcome.
Great. Were there any more questions? Anyone else have any other comments that they wanted to make? Tom, hi.
Hi. Yeah, I was just wondering, how transferable is this to other countries that are earthquake prone? What would another government need to do to adopt this approach?
This is a big issue actually. One of the Horizon project and also in this Dude project, we are trying to manage this process for this issue as well. Like when we have this construction waste here, like if we produce some material, it can be a building element of some part. We can also have like transit it to another European countries, and it can be used in its construction material, but it needs a good tracing mechanisms for this one. We call it as a material passport. If we have a material passport process for these building materials, then in global, in this between the countries, there can be like a transfer between these countries. This is the trying to do actually for this projects as well, for Horizon and other kind of projects, trying to make a kind of tracing mechanism for this waste materials, like material cadastry or material passport process. Actually, it's like digital material passport, like kind of platform trying to establish for this process actually. For the next couple of years, probably I also my colleagues will work on this, on how we can use in these buildings in other, or how we can export or import these buildings.
Brilliant.
It needs to be certificate. It needs to be certificate. It needs to be given this carbon emissions, energy emissions. That it needs to be give some digital and technical feasibility for these materials to be able to transfer between the countries. So it needs a platform. I think the Netherlands is the best country in this one to using waste materials and circular economy of these materials as well.
Thank you.
You're welcome.
Yes, it appears that you would need to have the infrastructure for demolishing buildings on purpose in place before you could bring it into kind of like a disaster situation. So the countries need to be prepared already to process the materials and have the factories with the sorting and the crushing and the kind of the process to kind of take it away. So is there something to be encouraging governments to set up the kind of the normal waste recycling of buildings kind of in these kind of perhaps more earthquake prone countries as well, kind of in advance of that, so it's not a disaster reaction, but it is something that there's already infrastructure in place to start processing the materials.
Actually, Turkey is quite experienced country because we have ongoing urban regeneration projects for last 20 years. So it's going on, like we are demolishing the building and building a new one. Urban regeneration sites, so many in every city nearly you can find, even social housing units as well. Quite so, construction industry is quite developed in Turkey. So when this earthquake hit this east part of the area, nearly affected 16% of the Turkey, nearly 11 cities affected from this earthquake. Is quite big issue for a country to manage it. But thanks to this construction industry, developed construction industry, and also the renewable projects, urban renewable projects, we are able to sort of this all the construction waste. It's still ongoing, but most of the part of the construction waste is used. So we have like some nearby cities of these cities to carry these rains to make a greening, crushing, and separating processes going on. Like it is just maybe after a few months later started to do, because you can't wait. You can't wait for the waste to stay there in the cities. You have to sort it immediately, otherwise it can produce some harmful chemicals. And also, the other issue is the storage. The big amount of ruins is quite difficult to store. Where are you gonna store it? Like all the part of the country needs to be protected. You know, like you shouldn't affect the environment of the storage area. Like, so you can't save this. You can't store these materials everywhere. So that's why you need to be fastly sort all the waste material. So it is still going on process, but as you say, it's maybe not an earthquake. It can be another disaster happen in another country, or even the war areas, you know, like Ukraine or Gaza, like so. It's also has so many ruins. So what will happen to these ruins? So it is you can't just waste and keep it there. You have to use it before it is occur some chemicals to the environment. So it is actually a global issue when we think, because if it has happened to few countries, it will affect other countries as well, because the environment, all atmosphere for all the people. So it's finally affect your country's air emissions as well. Like, yeah. It is
And
important.
there were some very big countries down at that bottom of that map that weren't doing quite as good a job as kind of the Netherlands and such, like kind of the large China circle, and kind of I was surprised New Zealand was down there, considering the kind of the earthquakes that they've suffered in the kind of the last decade. But that was really, really interesting, and thank you very much for kind of explaining it all to us today. And thank you to everybody for being here at this webinar. We have another one of this series next month, so we will send details to you all to join that meeting as well. But this afternoon, to say thank you very much to Fatma and to everybody else who has joined us today. So if you have any questions, feel free to drop us an email at UKCRIC. And we can pass them on to Fatma as well. Thanks very much for your time then. Goodbye, everyone.